Okay, in this presentation we will be looking at a random variables example. So here we will be calculating the expected power dissipated by a resistor. So this is a bit more of an applied example compared to some of the theoretical ones we might see otherwise. So let's get into it. Imagine selecting a resistor at random from a box containing resistors of 1 ohm, 2 ohm and 5 ohm resistors. And let's suppose there's an equal probability of each. Okay, so it's a 1/3 chance of a 1 ohm resistor, a 1/3 chance of a 2 ohm resistor, and a 1/3 chance of a 5 ohm resistor. Okay, so this resistor is then calculated to a live wire carrying a current I, which is an exponential random variable with parameter lambda equals 0.5, and this is independent of the resistor. That's important later on. Given that R represents the resistance of the chosen resistor, which could be a 1 ohm, 2 ohm, or 5 ohm resistor, and I is the current flowing through the circuit, the power dissipated by the resistor is defined as P equals I squared times R. What is the expected power? So that is our question. So let's identify the given variables. First off, we have the resistor values, 1 ohm, 2 ohm and 5 ohm, chosen uniformly at random, which is to say equal probability of each. And the current I is an exponential random variable with a parameter lambda equals 0.5. So what we're asked to do is calculate the expected value, the expected power, the expected value of P, E of P. Now P is equal to I squared times R, which we've gathered. So using the independence of I and R, the expected value of P is equal to the expected value of I squared times R, and this is equal to the expected value of I squared times the expected value of R. Okay. So I is an exponential random variable with parameter lambda. So just using our knowledge of the exponential distribution, the expected value of I is E of I, and that is 1 over lambda. The variance of I is the 1 over lambda squared. Now what we want is the expected value of I squared. So we're going to use the little formula, rearrange the formula for the variance just algebraically. So we have the expected value of I squared equals the variance of I plus the expected value of I to be squared. So that is 1 over 0.5 squared, which is 1 over 0.25, which is 4, plus 1 over 0.5 to be squared, and again that is 4 also. So the expected value of I squared is 4 plus 4 I should say, and that is equal to 8. Okay. Now the expected value of R is straightforward enough. This is a discrete random variable. There are three possibilities, 3 numeric values, and each are equally likely. So there's 1 times 1 over 3 plus 2 times 1 over 3 plus 5 times 1 over 3. So the expected resistance, the expected value of R is 8 over 3. So what we're going to do now is just piece these two together essentially. So the expected value of the power is the expected value of I squared times the expected value of R. That is 8 times 8 over 3, which is 64 over 3. So our conclusion, the expected value of power, the expected power dissipated by the resistor is 64 over 3 watts. If you're an engineering student, make sure to put in watts there and ohms and stuff like that. That's very important to get those units right. If you're a math student or something else like a statistics student, you probably might get away with just units of power or something like that, because you won't be expected to know it. All right, we'll leave it there.